Hello students, good day to each and everyone. I am here again, Samsudin and Abdullah, your online teacher in General Mathematics. I hope you are doing very well this time despite this COVID-19 pandemic. We are going to discuss about functions and their graphs. How important these functions in representing real life situations and how these basic functions help us making our daily life activities easier and meaningful every day. This online video presentation is talking about basic functions and their graphs. They are considered to be basic functions because they are very useful in solving problems, particularly the problems that we encounter in our daily life activities. And take note, most of the real life situations are being represented by basic functions, and sometimes we are going to sketch the graph of these functions in order to solve problems that we encounter. That is why we are going to make ourselves acquainted with these basic functions in order to make our life easier and meaningful every day. I am going to present to you the learning objectives. At the end of this video presentation, you are expected to demonstrate your understanding about a constant function, a linear function, and a quadratic function, and set up table of values for each of these basic functions in order to sketch the graph. We are now talking about constant function. But prior to that, I am going to explain first what is the meaning of constant. Constant is a number that has already a fixed value. It means that constant is not a variable. For example, 5. 5 is a constant. 6 is also an example of a constant. 0 is also a constant. Negative 5.1 is also a constant. It means that this number has already the fixed value. That is why if we are talking about constant function, it is a linear function. Take note, it is just only a type of linear function, and linear function will be explained to you in details in the second basic function. Now, it is a linear function for which the range, when we say range, it is a set of all resulting values of y, and this range does not change no matter which member of the domain is used. When we say domain, it is a set of admissible values of x. It means that whatever value of x being assigned to it, the value of y remains the same, does not change all throughout that given problem. The graph of this constant function is a horizontal line, and it is denoted by the equation y is equal to c, wherein c is a constant. The degree of a constant function is 0. What do you mean by degree? Degree of a polynomial or degree of a certain function refers to the highest exponent of x. Because if we are talking about function, we are going to always deal with the exponent of y, which is 1. The slope of a constant function is 0, and its y-intercept b is c. Now, what do you mean by slope? Slope refers to the slant of a line. And when we say y-intercept, it is an ordinate of a point along the y-axis in which the abscissa is equal to 0. Now, we will proceed with the examples. The direction is set up a table of values for each constant function and sketch the graph. We will proceed with problem number 1. Y is equal to 3. Now, 3 is our constant and y is our dependent variable. By the way, you have a variable x here,
But the exponent of the variable x here is equal to 0. That is why x raised to 0 is equal to 1. Therefore, 1 times 3 is equal to 3. Any constant is understood to have a variable x with an exponent of 0. But take note, 0 raised to 0 is not equal to 1. That is undefined. Variable beside the constant 3 is x and the exponent is 0. That is why x raised to 0 is equal to 1. 1 times 3 is equal to 3. Our equation is y is equal to 3. C is our constant, and that is automatically our y-intercept. And all constant functions have a slope of 0. Now, what is the meaning of a line with a slope 0? This line is a horizontal line. Now, what is the perfect example of a horizontal line? It is a line wherein that line is parallel with the sea level. That is the perfect example of a horizontal line, because the line in that floor might not be horizontal, because that line, if that is not parallel with the sea level, is still water. That is not a horizontal. So that is the perfect example of a horizontal line. Now, how are we going to sketch the graph of y is equal to 3? Since that this is a linear function, or the graph of this is a horizontal line, we just only need 2 points in order to sketch the graph of a line, because in geometry, 2 points can determine a line. This is the table of values wherein our x are negative 2 and 2. Any value of x, as long as it is a real number, must be acceptable. It means that any value of x assigned to it, the value of y remains constant, remains fixed at a given value of 3. That is why if x is equal to 2, our y is also 3. Now, how about if our x is 1 million? Our y is also 3. If x is equal to negative 200, our y is also 3. If you are going to assign values of x, you are going to start with a smaller number. The number on the left of the table must be a smaller number with a number on the right side. Now, if I'm going to assign values of x which are all negative, that numbers are still correct, because any number can be assigned to this particular x, because there is no restriction. But take note, since that this is a constant function, so when we say constant function, there is no variable x being seen. Although there is a variable x here, the exponent is 0. As what I have said, if x is having an exponent of 0, or any number with an exponent of 0 except 0 is equal to 1. 1 times 3 is equal to 3. That is why if our x is 100, 100 raised to 0 is equal to 1. 1 times 3 is equal to 3. That is the meaning of constant function. Any number assigned to x, the value of y remains constant. Now, how are we going to sketch the graph of this function? The first thing that we're going to do is to draw the Cartesian plane. We are going to draw first the vertical axis. Vertical axis is this one, and the horizontal axis is this one. And we are going to intersect these two axes at the origin. What is the best example of a vertical axis or a vertical line? The best example or the concrete example of a vertical line is a person with a good posture is standing, because the tree, the building, the post might not be vertical if this line is not perpendicular to the still water, because the base example of a certain horizontal line is a still water. Still water is a water not moving. So that is the base example or illustration of a certain horizontal line. Now, if that line is perpendicular with the still water, that is a vertical line. So when you say perpendicular, the angle inclined is 90 degrees. That is why x-axis and y-axis intersect at the origin, wherein these two axes are perpendicular with each other. Now, after having our Cartesian plane, we are going to put congruent units so that we can sketch the graph of any function on the Cartesian plane accurately. Now, this is negative 2. That is why you need, this is negative 1, then this is negative 2. And this is positive 2. Therefore, from the origin, you have positive 1, positive 2. You don't need to extend this Cartesian plane on the left side because you don't have negative 3 there. And so with this one, you just only put the units which are needed in the graph. You do not have your negative value in the y. But to make your graph more beautiful, you are going to have here negative 1. But if you don't want to have your negative 1 here because it is no longer needed in our graph, that is still okay. But take note, our y is 3. From the origin, you're going to move upward. This is 1, 2, 3, then up to 4. So that our graph will be very appealing to the eyes of the reader. Now, how are we going to plot this point? Now, from the origin, you are going to consider first the value of x. Our x is negative. From the origin, you are going to move going to the left if our x is negative. Take note, always consider first the value of x before going to the value of y. Since our x is negative 2, this is negative 1, negative 2. Now, our y refers to the movement of the initial point going downward if it is negative, going upward if it is positive. Therefore, our y is positive 3. We are going to move the initial point going upward. So, therefore, this is 1, 2, and 3. And this is our point with coordinates negative 2 and 3. We are going to plot this point. This point is positive and positive. Consider first positive 2, and that is our x. Okay, this is 1, this is 2, then our y is 3. Therefore, this is 1, 2, 3. This is our point with coordinates 2 and 3. Now, there are 2 points. Therefore, you can connect already these 2 points in order to have a line. Because in geometry, a minimum of 2 points can determine a line. Why do we need to have several points in which these points are still lying on the same line? We can construct a line with 2 points only. We just only consider 2 points if we are going to sketch the graph of a line so that it will reduce our efforts in graphing. After which, we are going to pinpoint that this line is given by the equation y is equal to 3. And don't forget to put the coordinates of the points beside the point. And don't forget the x-axis, putting the x here, and putting the y here. If you don't have a space here, you can have your x there. If you don't have a space there, you can put your y here. But don't forget, you're going to have the equal units of our axis in order to sketch the graph accurately. By the way, if a line is parallel with the still water, that is a horizontal line. It means that our line is not slanting. Therefore, our slope is equal to 0. Slope and y-intercept are the two most important properties of a constant function because it is also a linear function. And our y-intercept is automatically our constant. This is the very easy graph of a basic function is the constant function. We will proceed with example number 2. Y is equal to negative 2. What value of x can be assigned to y is equal to negative 2? Any value, any real number can be. If you want to have negative 1 million, you can. But can you think that if you have negative 1 million, is it realistic to graph it in the Cartesian plane? No. Therefore, just only select the values of x which are realistic in nature. These are the values of x. If you want to start with 0, the second number that you would like to assign to x must be greater than 0 because we are always following the concept of a number line in which number line is partitioned by an integer 0. To the right of 0 are all positive numbers. To the left of 0 are all negative numbers. Since you start with 0, you can have 1, you can have 2, you can have 3. I want 3 here. Now, if x is equal to 0, our y is equal to negative 2. If x is equal to 3, our y is negative 2. Whatever the constant, that is automatically the value of y. Now, you have already 2 points here. Therefore, you can sketch now the graph of the constant function. Take note, the graph of all constant functions are parallel with the x-axis. But if our constant function is y is equal to 0, our horizontal line coincides with the x-axis. Therefore, the equation of the x-axis is y is equal to 0. Now, we are going to draw our Cartesian plane. Now, this is our Cartesian plane. In having our Cartesian plane, you are going to draw first the vertical line. After drawing the vertical line, you are going to consider the coordinates that you have on the table, and you're going to imagine where are you going to put your x-axis in order to utilize all the space here. By the way, in our Cartesian plane, there are 4 quadrants. This is quadrant 1. Coordinate of x is positive. The coordinate of y is positive. Quadrant 2, the coordinate of x is negative, the coordinate of y is positive. For quadrant 3, all negative, the coordinate of x is negative, the coordinate of y is negative. Quadrant 4, the coordinate of x is positive, the coordinate of y is negative. Therefore, quadrant 1 is positive and positive. Quadrant 2 is negative and positive. Quadrant 3 is all negative. Quadrant 4, positive and negative. Quadrants are read in counterclockwise. This is our x-axis and this is our y-axis. If you want to remove this negative 2, you can do. Until here only, you can do. For your y, you don't need the positive y. If you have your y-axis until here only, that can also be. But I don't want that you are going to draw a Cartesian plane in which that quadrant is not necessary for your graph. That is why you just only draw the quadrants which are useful in your graph to make your graph appealing. Now, how are we going to sketch this point? Take note, any value of x assigned to it, our y remains constant at negative 2. which is not 3. Take note, whatever the constant value in our constant function, that is automatically the value of y. Now, if x is equal to 0, our y is negative 2. Where is that? Since our x is 0, don't move to the left, don't move to the right. Just proceed automatically with the given value of y. Since that the value of y is negative, move downward. 1, 2. Therefore, the coordinates of this point is 0 and negative 2. And this is our y-intercept. Y-intercept is an ordinate of the point along the y-axis. Now, how are you going to sketch this point on the Cartesian plane? 1. Take note, our x is 3. 1, 2, 3. And your y is negative 2. Then this is 1, 2. Therefore, this is your point with coordinates 3 and negative 2. If you are going to connect these 2 points, you have a line. Now, in your graph, for example, if we have our assignment, for the graph, you are going to use the red ball pen so that the graph will be emphasized. And if you want to have a blue color for your point, that can be. But do not use colored ball pen for the coordinates as well as for the variable. You can just only use either black blue color only. This is the equation of this line, y is equal to negative 2. This is very simple. Now, the slope is equal to 0 and the y-intercept is negative 2. We will proceed with linear function. Linear function is the second easiest basic function. The word linear comes from the word line. Therefore, if you hear the word linear function, the graph is a line. Linear function is a function whose graph is non-vertical straight line. It is denoted by the equation y is equal to mx plus b. This equation is in slope-intercept form, where m is the slope of the line and b is the y-intercept. The degree of a linear function is 1 because the highest exponent of x is 1. If we are talking about function, our y is always equal to 1. So that is a function. We will proceed with examples. Set up or construct a table of values for each linear function and sketch the graph. Number 1. Y is equal to 2x minus 3. Take note, this equation is already in the slope-intercept form, wherein our m is 2, and take note that m is our slope, and our b is negative 3. Therefore, y is equal to 2x minus 3 is a linear function already in the slope-intercept form. Now, how are we going to sketch the graph? By setting up table of values first. What are the values of x that you want to assign? Any value. There is no restriction for the value of x. If you want x which is negative numbers, that can be. If you want x which is 0, that is also possible. If you want x which is positive, that is possible. Now, any value of x can be. If we are talking algebra, we are always using the variables x and y. X is our independent variable. It means that any value can be assigned to it, and you cannot determine the value of y unless the value of x is given. That is why independent and this is dependent, because y always depends upon to the value of x. Now, this is our table. Our x is negative 1. I start with negative 1. If x is equal to negative 1 times 2 is negative 2. Minus 3 is negative 5. Negative 2 plus negative 3 is negative 5. Negative plus negative is negative, not positive. Do not apply the rule in multiplication in adding sign numbers because rules in addition and subtraction is different from the rules in multiplication and division because for 18 years of being a teacher in both private and public school, I encountered that students are having a positive result if they are adding two negative numbers. And that is very wrong because when you say negative, that is utang. If you're going to add utang with another utang, the result is utang. That is the concept that you are going to consider for you to be not confused with the rule in adding sign numbers with that of the multiplying or dividing sign numbers. If x is equal to 0, 0 times 2 is 0. 0 minus 3 is negative 3. Therefore, you only have the negative coordinates. Now, the first thing that you're going to do is to draw your y-axis. And after drawing the y-axis, you are going to anticipate where are you going to draw your x-axis in which you can have just only the needed quadrants for your graph. This is our graph. Now, this is your y-axis. Since that you do not have a positive y and that of the positive x, so therefore you just only need the third quadrant here as well as the y-axis because you have a point along the y-axis here because you have the abscissa 0. Therefore, this is our Cartesian plane. Now, how are we going to plot this point? Negative 1 and negative 5. This is located in the third quadrant because our x is negative 1. Then going downward, this is negative 1, negative 2, negative 4. This is negative 5. And this point with coordinates negative 1 and negative 5. Now, we will proceed with the second point, 0 and negative 3. Take note, abscissa refers to the movement of the initial point either in the left side of the origin or to the right side of the origin. If our abscissa is negative from the origin, go to the left. If our abscissa is positive, go to the right. Before considering the value of y, you have to initially move the point from the origin using the abscissa. Don't be confused with the initial movement of the point. Always consider the value of x or the abscissa. Now, since that our abscissa in our second point is 0, do not move to the right nor to the left. Go directly to the movement of the point going down since your y is negative 3. So therefore, this is negative 1, negative 2, and this is negative 3. Some of you, this plotting of points are very easy, but take note, we always start with a basic one because you cannot go with the complex problem if you don't know the basic one. Now, if you are very expert in this graphing of these basic functions, you can make your own problems and you can practice solve it by yourself. If you just only end your line until here, that is also correct. But I just only extend the line so that my line can intersect x-axis. For me, this is more appealing. Don't forget to have the coordinates of the units and the units of the two axes must be congruent with each other so that you can always get a very accurate graph. So this line in red mark is given by y is equal to 2x minus 3. When you say slope, it is a constant. When we say constant, no more variable. Slope is just only the numerical coefficient of the term. Take note, there are two types of coefficient. We have the numerical coefficient and we have the literal coefficient. Literal coefficient is variable. Numerical coefficient is a constant. When we say constant, it has already the fixed value. 2 is a fixed value. If you put x here, it is no longer a fixed value because any value can be assigned to x. That is why x is not a fixed value. X is not a constant. That is a variable because the word variable is coming from the verb vary. When you say vary, to change anytime depending upon the person who is going to assign value at x. So that is why x is independent variable. And our slope is 2 and our y-intercept is -3. Now take note, this is automatically in slope-intercept form. That is why your y-intercept is -3. What is the meaning of this? This is an ordinate of the point along the y-axis wherein the abscissa is equal to 0. This is our y-intercept. This is an example of a linear function. We will proceed with number 2. Y is equal to -3 halves x plus 4. This is also in slope-intercept form. Therefore, our slope is the numerical coefficient of the x, and this is -3 halves. And our y-intercept is equal to 4. Therefore, we have a point along the y-axis which is having coordinates of 0 and 4. Take note, the sign of our slope signifies the trend of the graph of the line. If the slope is negative, our line is decreasing. That is why through the use of the slope, you have already in your mind what will be the possible physical appearance of our line. Is it decreasing or increasing? Since that our slope is negative, from left to right, that is going downward because this is decreasing. If our slope is positive, from left to right, that is going upward. How are we going to assign values of x? Because the instruction there is set up table of values and sketch the graph. These are the values of x that I assign. Now, if you have the slope which is fraction, you are going to assign values of x which are divisible by 2 so that you cannot arrive at a decimal number with the value of y, because if you are going to have a point with coordinates having a decimal number or fraction, it's very hard to sketch the point with fractional coordinates or decimal numbers as our coordinates. That is why if you're going to assign value of x here, you're going to consider the denominator 2 here. You can have 0 here. You can have -6. You can have -4 because all of these numbers are divisible by 2. I want -2 here. Substitute x with -2. Negative times negative is positive already. Then we have 2 times 3 is 6. 6 divided by 2 is 3. Then 3 plus 4 is 7. Or if this is -2, cancel it. And you have -1 times -3 is +3. Then 3 plus 4 is equal to 7. If we will be in the higher algebra already, in which we have the complex solutions, another strategy will be used by me. You cannot anymore see my face because I'm going to have the writing pad, and you can just only see my solution on the screen. That will be the online strategy that I'm going to use if we will be in the higher level of algebra lessons. Now, another value of x being assigned to it is 4. Take note, I am arranging the value of x in increasing order. Take note, you need only 2 points for a line. Why having 3 points? That is just only adding your effort. You can draw a line with 2 points only. If x is equal to 4, take note, you can have the arrangement of the values of x and y vertically like this one, or you can have also the horizontal arrangement, which is convenient to you, can be. If x is equal to 4, 4 divided by 2 is equal to 2. 2 times 3 is 6, and that is negative. negative 6 plus 4 is negative 2. Because you have a negative 6 added with positive 4, you're going to subtract. If you're going to add two numbers having different signs, you are going to subtract, and whatever the difference, copy the sign of the bigger absolute value. Since that 6 has a negative sign of the difference will follow the greater absolute value. Okay, you can have also another way of getting the value of y here. 4 times 3 is 12. 12 divided by 2 is 6. Take out, this is negative. Therefore, negative 6 plus 4 is negative 2. Therefore, after having our values of x and y, you can have now your Cartesian plane. Draw a vertical line first. Take note, you need only negative 2 in your x and negative 2 in your y. We are going to sketch this point. Negative 2 and 4 do not go to the ordinate unless you pass through with the x. Because if you go directly to the value of y without passing by in the value of x, that is trespassing, and that is a violation of the rule. Therefore, if you are going to sketch the graph, you are going to start with the abscissa. From the origin, go to the left because our x is negative. 1, 2. This is 1, 2, 3, 4, 5, 6, 7. Therefore, this is the point negative 2 and 7. These are the coordinates of this point. Now, we will proceed with the second point. Take note, if you're not having your units of the x and y axis congruent with each other, you cannot arrive at a accurate graph. You can observe. Since that this is accurate because the units are congruent with each other, our y-intercept is 4 and that is correct. Now, if this line does not pass through in this particular point, meaning your graph is wrong because it is not accurate. So that is why you are going to always consider the units of our x and y axis. Now, if x is equal to 4, y is negative 2. So, from the origin, go to the right 4 units. 1, 2, 3, 4. Then, your y is negative 2. Go downward, and this is your point with coordinates 4 and negative 2. Take note, you are going to indicate the coordinates beside our point. Okay, now, connecting the 2 points, this is your line, and the line is decreasing. Why decreasing? As you increase the value of x, the value of y becomes smaller. That is why decreasing. If it is increasing like this one, as you increase the value of x, the value of y also increases. Now, what is now our slope? Our slope is negative 3 halves, and our y-intercept is 4. Now, we are going to check the slope using the graph. How are we going to get the slope using the graph? Because sometimes I am going to give you the graph and you're going to identify the slope by inspection only. You can have here, you can get your slope here, you can also get your slope here because slope is equal to change in y over change in x, or slope is equal to rise over run. Rise is change in y. Run is change in x. Since that these are the two given points, so we are going to consider this one. Starting from this point, we are going to go to this point using the coordinates. We will start from y. Take note, you are going to always start with change in y because that is our numerator. Change in y is either going down or going upward. Change in x is either going to the right or going to the left. That is why 1. And this is negative. Take note, that is looking for the slope. 1, 2, 3, 4, 5, 6, 7, 8, 9. Stop. Then go to the right because this is your point. That is your destination. 1, 2, 3, 4, 5, 6. And this is negative 9 over 6. Negative divided by positive is negative 9 over 6. Reduce that into lowest term by dividing 9 by 3 is equal to 3. Then dividing 6 by 3 is equal to 2. That is why our slope is negative 3 halves. You can also have the slope like this. Change in y. 1, 2, 3. That is 3. Automatically reduced into lowest term already. Since that you're going to move to the left, that is negative. And that is change in x. 1, 2. Therefore, positive 3 over negative 2 is negative 3 halves, and that is our slope. You can also get the slope here. From this point, your direction is going there, and you're going to follow the x coordinate and the y coordinate. The y coordinate first because rise over run. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then go to the left, and that is negative already. And just a while ago is positive, and today is negative. From here, go to the left, and that's negative. Positive 9 divided by negative already. This is 1, 2, 3, 4, 5, 6. Positive 9 divided by negative 6 is negative 3 halves. We will proceed with the last basic function, this second video presentation, and that is talking about quadratic function. Quadratic function is a function whose graph is a parabola. Parabola has four types. We have parabola that opens upward, and we have also a parabola opens downward. And these are the parabolas that are being referred to us by quadratic function. Because if we are going to have the vertical line test, that will not intersect the parabola in 2 points. We have another two types of parabola. We have parabola that opens to the right. If we are going to have the vertical line test, that parabola intersects the vertical line at 2 points. That is no longer a function. And we have also a parabola that opens to the left. Same thing will be encountered in intersecting the parabola opening to the left. There are 2 points of intersection between the parabola and that of the vertical line. Therefore, it is not a function. We are just only referring to parabola opening upward and parabola opening downward. Quadratic function is denoted by the vertex form. Y is equal to a quantity x minus h, quantity squared plus k, where h and k is the vertex and x is equal to h is the axis of symmetry. And its degree is 2. Construct a table of values for each quadratic function and draw the graph. This is our example number 1. And this is the very basic quadratic function. So where's the basic? Simple, but very important. That is the meaning of basic functions. Basic functions are functions which are simple, but you cannot underestimate its importance in our daily life activities because most of the real life activities are being represented through functions, and they are the basic functions. Y is equal to x squared. Since that the degree of a quadratic function is 2, it is no longer a line. In algebra, you need 5 points in order to get the very accurate curve. Not like with the line that you only need 2 points, minimum of 2 points for you to sketch the graph. in algebra. 2 points are not enough. 3 points are not also enough in algebra. But we need 5 points in order to sketch the graph. And the most important point for this quadratic function is our vertex. Our vertex is given by h and k. Since that our quadratic function contains only the quadratic term, it is understood to be that our h and k are 0 and 0. Therefore, our vertex is the origin of the Cartesian plane. And if we are going to set up table of values, this vertex must be in the middle of our table of values because we are going to consider that the points in our quadratic functions are symmetric with each other. And this is our table. Our vertex, which is the origin, and the coordinates are 0 and 0, must be put in the middle. Okay, this is it. Now, from this, you are going to assign values of x, and you are going to use the concept of number line in which from the first value here going to the last value in your table, the numbers must be in increasing order with 1 as the common difference. Therefore, if your abscissa of the vertex is 0, 0 minus 1 is negative 1. Then negative 1 minus 1 is negative 2. Then from 0, 0 plus 1 is 1. 1 plus 1 is 2. Although you can assign any value of x here, but if you don't use the technique, how can you sketch the graph with points which are not symmetric with each other? When we say symmetric, just only reflection of each other. And that is the importance of axis of symmetry. X is equal to h. Meaning, whatever the abscissa of the vertex, and that is your h. Therefore, x is equal to h. Our abscissa of the vertex 0. Therefore, x is equal to 0 is our axis of symmetry. And that is our y-axis. These are the values of x. Now, if x is equal to negative 1, y is positive 1. Negative 1 times negative 1 is positive 1. You don't need to solve this because whatever the value of y here is also the same there and so with here because they are symmetric with each other. The points here are symmetric with each other. When we say symmetric points for function, two different abscissas will have the same ordinate. And that is symmetric with each other. Now, if x is equal to negative 2, negative 2 times negative 2 is equal to 4 because we have the exponent 2 there. Now, to check, 1 times 1 is equal to 1. 2 times 2 is equal to 4 because this is the value of x2. Substitute there. Now, these are your points. You're going to draw your vertical axis since you have negative 2. So, you have two congruent sides of the x-axis. And so, for our y-axis, you don't need the negative because there is no negative value of y here. You only need the upper side of the y-axis. Therefore, you need the first and the second quadrant only. This is the graph of our quadratic function. Y is equal to x squared. If you're going to plot the points of the quadratic function, start with the vertex. Then consider the two symmetric points. Our vertex is 0 and 0. And that is the origin. This is it. And these are the coordinates. Now, if x is equal to negative 1, our y is positive 1. From the origin, move to the left. From this initial point, move upward because your y is positive. And this is your point And these are the coordinates, -1 and 1. Now, consider this one because these points are symmetric with each other. This is the axis of symmetry, meaning whatever points that you have here, it has the corresponding point symmetric with it. Therefore, I am going to plot this point. X is equal to positive, move to the right. Then move upward because your y is positive, and this is a point. Okay, you have already sketched the 3 points, the vertex and the first pair of symmetric point. So we will proceed here. If x is equal to -2, -1, -2, then y is equal to 4. Okay, 1, 2, 3, 4. Therefore, the coordinates of this point are -2 and 4. Now, reflect this point to the other side of our graph because they are symmetric and you can get this point. And that is 2 and 4. Therefore, 1, 2. Then move upward 4 units. 1, 2, 3, 4. And this is the point with coordinates 2 and 4 symmetric with the point with coordinates -2 and 4. And this point 1 and 1 is symmetric with the point -1 and 1. And the origin is symmetric with itself. Okay, symmetric with itself. Now, our axis of symmetry is this one with green color. Then, we are going to label the important characteristics. So, our vertex is the origin, and our axis of symmetry is this one. Then, don't forget, use red mark for your parabola or for your graph. And that is our standard in our subject only. And this is the graph of y is equal to x squared. We will proceed with example number 2 under quadratic function. Y is equal to x squared minus 2. You are going to scrutinize the given function. Our given quadratic function has only the quadratic term and that of the constant term. We do not have the linear term. If that is the case, if we have only the quadratic term and we do not have the linear term, our vertex is found along the y-axis because you do not have the linear term. No movement or no shifting of vertex to the right or to the left because there is no linear term. Therefore, that is the first thing that we're going to consider is to observe the form of the quadratic function. And that is to identify first the vertex because after identifying the vertex, you're going to put that vertex in the middle of our table. Therefore, our vertex is 0 and -2, and this is our table, and this is it, 0 and -2. Therefore, from here, decrease 1 unit going to the left so that you can have the value of x here, and so with the value of x there. So this is -1, minus 1 is -2. Now, if x is equal to -1, -1 times -1 is 1. Minus 2 is -1. If x is equal to -2, -2 times -2 is +4. 4 minus 2 is 2. These are two symmetric points, and this is a pair of symmetric points. Now, we are going to check if we have the same ordinate here. 1 for your x. 1 times 1 is 1 minus 2 is -1. Correct. That is why, if you are going to have this technique, you can just only solve the left side or the right side of the quadratic function and just only copy the ordinates because same, since you already put the vertex on the middle of our table. If x is equal to 2, 2 times 2 is 4, minus 2 is 2. And this is our graph. Take note, the opening of our parabola is signified by the coefficient of the quadratic term. If the coefficient of the quadratic term is positive, our parabola opens upward. If the coefficient of the quadratic term is negative, our parabola opens downward. We are going to plot the points. In plotting the points of the quadratic function, you are going to start with the vertex. Then our vertex is along the y-axis. Our x is 0 there. Do not go to y unless you go first to the x value. Please. Because you are doing the trespassing. Trespassing is the violation of a very simple rule. Our x is 0, therefore do not move to the right, do not move to the left, go directly to the direction of the y. So if negative, direction is downward, 1, 2, and this is our vertex with coordinates 0 and negative 2. Then here, this is in the third quadrant because all negative. So this is negative 1, then negative 1. This is the point with coordinates negative 1 and negative 1. And consider this one for the symmetric point of this point. And this is 1 and negative 1, positive 1. Going downward because this is negative 1. And this is our point. Now, we will proceed with negative 2 and 2. From the origin, move to the left 2 units. 1, 2, negative 2. And move upward, 1, 2. And these are the coordinates, negative 2 and 2. And consider the symmetric point of this point. And this is it. 2 and 2 from the origin. 1, 2. Then go upward. 1, 2. And these are the coordinates. 2 and 2. Then you are going to connect the points with a smooth curve. Do not connect the points with a line because this is not a line, this is a curve. Therefore, you're going to connect it smoothly, in which the left side of the graph is just only a reflection of the right side. Therefore, whatever the physical appearance of the graph here must also be the physical appearance of the graph there. Because this graph is the mirror of this one, of this graph. Because the mirror is the axis of symmetry. And this graph is y is equal to x squared minus 2. And drawing the axis of symmetry, this is it. Axis of symmetry is our y-axis. And that is x is equal to 0. The properties of our quadratic functions are the vertex, and the vertex is 0 and negative 2 ray to signify that this 0 and negative 2 is our vertex. And our axis of symmetry is this line, and this is our y-axis with equation x is equal to 0. Number 3, second to the last example of quadratic function. Y is equal to negative quantity x minus 3 quantity squared. Take note, since our quadratic term is negative, the parabola opens downward. Therefore, if your graph is opening upward, that is automatically wrong because mathematics is very perfect. If our quadratic term is negative, our opening of the parabola is downward. If the quadratic term is negative, the concavity of the parabola is downward. If it is positive, the concavity of the parabola is upward. Concavity of the parabola refers to the opening, either upward or downward. If our quadratic term is positive, our parabola is concave upward. If it is negative, our parabola is concave downward. This is your vertex and the coordinates are 3 and 0. 3 minus 1 is equal to 2. 2 minus 1 is equal to 1. That is the thing that you're going to do. Decrease 1 unit going to the left. Then increase 1 unit going to the right. 3 plus 1 is 4. 4 plus 1 is 5. And you have already this very good values of x so that you can have the symmetric points. Look at this one. To check, we are going to substitute x, which is 2. 2 minus 3 is equal to negative 1. Negative 1 raised to 2 means negative 1 times negative 1 is positive 1 already. Positive 1 is the result of this exponential expression times negative 1 is negative 1. Now we will proceed here. 1 minus 3 is negative 2. Negative 2 times itself, because we have the exponent 2, is 4. Because negative times negative is positive. Positive 4 times negative 1 is negative 4. 4 minus 3 is 1. 1 raised to 2 is 1 times negative 1 is negative 1. Then 5 minus 3 is 2. 2 raised to 2 is 4. 4 times negative 1 is negative 4. And take note, you don't need the negative x-axis because all the values of x are positive. You don't need also the positive y-axis because you do not have the positive value of y here. Therefore, draw first your vertical axis. After drawing the vertical axis, like this one, then draw your x-axis like that one. Do not draw like this, like that, in which you need only the space here. Okay, what happens to this space? Utilize that for some other important solution, for example. Therefore, this is our graph. Our vertex is 3 and 0. Take note, the value of k does not represent the y-intercept. Our y-intercept here is negative 9. Why negative 9? Negative 3 times negative 3 is 9. 9 times negative 1 is negative 9. Meaning, graph passes through in the point with coordinates 0 and 9. But we don't need that because we have already here the graph, no? If x is equal to 2, substitute 2 minus 3 is negative 1. Negative 1 times negative 1 is positive 1 already. Then positive 1 times negative 1 is negative 1. 1 minus 3 is negative 2. Negative 2 times negative 2 is positive 4. The result here is positive 4, then multiply it by negative 1, and this is negative 4. 4 minus 3 is 1. 1 raised to 2 is 1. 1 times negative 1 is negative 1. If our x is 5, 5 minus 3 is 2. 2 raised to 2 is 4. 4 times negative 1 is negative 4. Then we are going to plot the points. 3. 1, 2, 3. Do not move upward nor downward because your y is 0. And if x is equal to 2, y is negative 1. 1, 2, then negative 1. This is it. The coordinates are 2 and negative 1. If x is equal to 4, y is negative 1. 1, 2, 3, 4. Then move downward and this is it. The coordinates are 4 and negative 1. Now, if x is equal to 1, y is negative 4. 1. Then 1, 2, 3, 4. This is our point with coordinates 1 and negative 4. If x is equal to 5, y is equal to negative 4. 1, 2, 3, 4, 5. Then count downward. 1, 2, 3, 4. This is our point. Take note, these 2 points are symmetric with each other. How can you say that they are symmetric? Same ordinate with 2 different abscissas. Same ordinate with 2 different abscissas. Take note, this is not 1 to 1. Now, our axis of symmetry is this one, passing through the vertex. Therefore, our vertex is 3 and 0. And our axis of symmetry is x is equal to 3. And that is the line passing through the point 3 and 0. We will proceed with the last example of a quadratic function. Our vertex, -2 and -1. Why -2? X plus 2 is equal to 0. Solve for the value of x. X is equal to -2. And this is our k. Therefore, this is it. What will be the values of x? In which that will be in increasing order. What you need to do, from the abscissa of the vertex, -2 minus 1 is -3. -3 minus 1 is -4. Then -2 plus 1, because to the right, take note, from the abscissa of the vertex, to the right, you're going to add 1 to the succeeding term. Then, to the left, subtract 1 to the preceding term. So, therefore, -1 plus 1 is -1. -1 plus 1 is 0. You can have the symmetric points here. And this is it. Symmetric points are points with 2 different abscissas with 1 ordinate. Now, we are going to solve. To check, we will start from the vertex. This is just only to counter check. -2 plus 2 is 0. 0 raised to 2 is 0. Times 2 is 0. Minus 1 is -1. That is correct. If x is equal to -3, -3 plus 2 is -1. -1 raised to 2 is +1. Then 1 times 2 is 2. 2 minus 1 is 1. If x is equal to -4, -4 plus 2 is -2. -2 times -2, because exponent 2 means multiply it by itself 2 times, is equal to 4. 4 times 2 is 8, minus 1 is 7. -1 plus 2 is 1. 1 raised to 2 is 1. 1 times 2 is 2, minus 1 is 1. If x is equal to 0, 0 plus 2 is 2. 2 raised to 2 is 4. 4 times 2 is 8. 8 minus 1 is 7. And this is it. Take note, as you have observed here, our parabola has a narrower opening, meaning the opening is smaller compared with the 3 previous parabolas, in which the previous parabolas have 1 as the absolute value of the coefficient of x. Here, the absolute value of the coefficient of x is 2. It means that if the absolute value of the coefficient of the quadratic term becomes larger, opening of the parabola becomes narrower. If the absolute value of the coefficient of the quadratic term is smaller, the opening of our parabola becomes wider. If the coefficient of the quadratic term is positive, our parabola opens upward. If our coefficient of the quadratic term is negative, our parabola is opening downward. Now, if your graph, for example, is opening downward, that is automatically wrong because I can automatically identify the opening through the coefficient of the quadratic term. We are going to sketch the graph. Always start with the vertex, -2 and 1. Where is it? 1, 2, -2, then move downward. This is it, -2 and 1. This is the point. Then, next, -3 and 1. 1, 2, 3. And +1. -3 and 1. Then, you are going to consider the symmetric points for you to have the easy way of graphing. If x equal to -1, y is 1. So therefore, from the origin, move upward. So -1 and 1. So these are the symmetric points. Take note, don't forget to indicate the coordinates of each point that you have in your graph. Then you don't need to extend your x-axis here. You don't need to extend your x-axis here because you don't need this area and that area. We will proceed. If x is equal to -4, y is 7. 1, 2, 3, 4. Then move upward because your y is positive. 1, 2, 3, 4, 5, 6, 7. This is it. If x is equal to 0, y is 7. Take note. This is our y-intercept is 7. How did you get that 7? Here. 2 times 2 is 4. 4 times 2 is 8 minus 1 is 7. Y-intercept is the ordinate of the point along the y-axis. Point along the y-axis, the abscissa is 0. Okay, 1, 2, 3, 4, 5, 6, 7. This is it. Then don't forget to put your x-axis and your y-axis there. Then take note, our parabola is narrower. It means that the opening is smaller compared with the parabola with smaller absolute value of the coefficient of the quadratic term. If I am going to have here 3, the opening is smaller than this one. If that is -4, the parabola is opening downward and smaller than this, of course. Then, the axis of symmetry is this one. And the vertex is -2 and -1. And the axis of symmetry is this line. I just want to remind you before we will end the second video presentation that your assignment in the first video presentation should be accomplished because that will let you to learn the concept of functions and relations represented by ordered pairs, table of values, arrow diagrams, equations, and graphs. In the next video presentation, we will be discussing the graphs of other basic functions like, for example, cubic function, identity function, and absolute value function. And in the next video again, we will be discussing piecewise function and we have the applications of basic functions in solving real life situations, or how are we going to represent the real life situations that we encounter through basic functions. That's all. Thank you very much.